Hello guys, welcome back to Maison African Motives. Still working on A-level mathematics. We have got questions that we are going to revise on integration. We talked about this part, referred to this introduction and questions. So if you haven't watched those questions, the introduction part, make sure that you watch the videos first so that you can understand this revision concept that you're going to do in this typical class. So we are given one of the question papers that we are going to refer to in our revision, where we are given on question number 18 that it is given that f of x is equivalent to 3x plus 4, everything over x minus 4 into x squared minus 8. And we are asked on this question A to express f of x in partial fractions, or to express this into partial fractions. All right. So this is not a matter of fact. Actually, from our introduction, we referred to this, or we talked about this typical question. So I'm just going to write our f of x separately so that we can have this question properly. So that's f of x. In this case, we are given that it is equivalent to 3x plus 4, everything over the expression of x minus 4 into x squared minus 8. So this is the part that you are given in this case to express into partial fractions on the first part, which is our item A. We know that into partial fractions, we are going to separate this into fractions depending with the number of brackets that we have in the denominator. So the first thing we are going to check, okay, can we factorize these denominators that you're given? X minus 4 is already in simplest form. We check x squared minus 8, which we can't actually have this in a factorized manner because 8 is not a perfect square. If it was something like maybe x squared minus 16 like this, we know that this is a difference of two squares, which is going to give us the square root of 16 in this case, which is a 4. So we're going to add, and another bracket is going to subtract. But in this case, we've got 8, which cannot be written in terms of a number to a perfect, to a power of 2, like a perfect square. So it's not a perfect square, this 8. So meaning we can't actually factorize direct from our difference of two squares. So what are we going to do? We are going to refer to this as a quadratic expression. Remember, we had quadratic factors, which when you write them, we write them as ax plus b over that quadratic expression of ax squared plus bx plus c. So that is the concept that you're going to apply since we can not factorize this. So that means in this case, we are going to have our f of x, which is this part, or we can just, okay, let me just write this separately so that I do not confuse you guys. I'm just going to write this part as it is. So it means that 3x plus 4, everything in this case, we are going to divide by x minus 4 into x squared minus 8. So this is going to give us the first part, that's a linear expression, which is just a over x minus 4, plus we separate now the quadratic, the one that I was referring to. So since we have already used a, so we are going to start with a b on this. So this is going to be bx plus c. So plus bx plus c like this. So that is how you present your quadratic expression over the ax squared plus bx plus c. It represents that quadratic expression that you're given, which is in this case is the x squared minus 8. So it's a part that cannot be factorized, like x squared plus 4. We can have something of that nature, x squared plus 4. This cannot be factorized. X squared minus 3. This cannot be factorized. So that's a quadratic factor. So you're going to refer to it as ax plus b. So in this case, it's bx plus c. So this is what we have, guys. Then we can separate. Remember, we are going to equate our numerators in this case. So that means if we are to express the numerator of the first fraction on the left-hand side, that's 3x plus 4, which is equivalent. On this side, we are going to divide the LCM. So this will be your LCM, because remember, you expanded these into these two. So which means if you divide x minus 4 and x minus 4, this will cancel. You remain with x squared minus 8. So it's going to be a into x squared minus 8. plus, we have a plus here, so it's x squared minus 8 and x squared. These two, they will cancel. You remain with x minus 4. So it's going to be the product of bx plus c times the factor that is remaining, which is the x minus 4 in this case. All right, so this is what you're going to have. So from this part that you are given, we can actually simplify this further by finding, that is to find the values of A, B, and C, that is the constants. So how can we find the values? We can start by this bracket, because it's a linear expression. So we can express this to equate it to 0 so that we can eliminate this whole part. So when letting the x minus 4 to be equal to 0, that means our x at that moment is going to be a 4. So that means if our x is equivalent to 4, this whole bracket is going to be equal to 0. So when x is equal to 4, that means we are going to substitute in every part that has got x. We are substituting a 4. So the first part, that's 3 times 4. So this is going to be 3 by 4 plus 4 in this case, which is equal to, here we are going to have 4 squared minus 16. So that is 4 squared minus 8. So that's 4 squared minus 8 times a. On this part, since this is the bracket that gave us a 0 this place. So which means whatever that you're going to obtain is going to be a 0. So 0 times this, that's a 0. We are left with this part. So we can solve for a. On this part, we are going to obtain 16, which is equivalent to 8a. So we can divide by 8 both sides. That means our a is equivalent to 2. So we have the value of a, which is 2 in this case. So from the value of a that we have, how can we determine other values? Or from this equation that we have in this case, how can we determine the remaining terms, which is B and C? So we are going to see that it's very important. It's impossible for us to find a factor from x squared minus 8, because remember, it's a quadratic factor which cannot give us exact terms. So we're going to leave it like that. So the next step that we have is to expand. All right, so we have the value of a, so we're going to expand so that we can equate the coefficients. By doing so, we are having the exact value of a. All right, so let's expand this part here. You can just expand it aside. So we are going to leave the left-hand side as it is. That is 3x plus 4 is equivalent to a and x squared. That's ax squared. A and minus 8, which is minus 8a. So we have expanded the first bracket by a. On the second part, we are given 2 brackets in this case. So you're going to expand it in the normal way that you do on a quadratic factors. So it's bx and x, which is going to be b. So take note here, there's a plus. So a plus does not affect. Okay, let me just put this here in a bracket so that we can understand. But a plus does not affect. Okay, let me explain it this way because it's going to waste us a lot of time here. A plus times any term that you're going to have, it is going to, these signs, they're going to remain as they are if you multiply by a plus. So here we've got a plus, so which means whatever that you're going to have is a product of these 2 brackets. So that means the bx and x is going to give us the bx squared. The bx and the minus 4 is going to give us the minus 4bx. The c versus x is going to give us cx. C and negative 4 is going to give us negative 4c. So this is what is going to give us a negative 4c, sorry. So this is a negative 4c in this case. So how do you determine, or how are you going to obtain the values of a, b and c, which is the remaining? We equate the coefficients from the terms that we are given in this case. Okay, let's take this part that has got x squared, x squared. We are referring now to the coefficients of this x squared. So if we are to take the coefficients of x squared in this case, on the left-hand side, we do not have x squared. It's a linear expression. So it means it was added to 0x squared. We are not having this 0 here. So we are going to have this as like 0x squared. So which means the coefficient of x squared on that part was a 0. So which means having the coefficient of x squared, in this case, 0 is equal to the coefficient of x squared on the left-hand side, which was not there. So it's going to be a 0. On the right-hand side, we are going to refer here the coefficient of x squared, which is a, the coefficient of x squared on the other part, which is a b, that's a plus b. So these two, they are equal, the left-hand side and the right-hand side. So that can be an advantage for us. Since we are to calculate the value of b, because we are given the value of a, which is a 2. So this can help us now to determine our b, because we know that a is equal to 2. So if we can transpose 2 to the other side, it's going to be 0 minus 2, which is minus 2 is equal to b. So that's b is equivalent to minus 2. Okay, so in the same sense, that is what you're going to do also for c. So c is affected on the coefficients of x, is also affected on a constant. So on this one, you can use whatever that you want. Okay, so for me, I'm just going to take constants in this case. So working with a constant terms, that is constant, only the constants. On the left-hand side, our constant, that's a 4. So that means 4 is equal to, on the right-hand side, constants, we are referring to these terms where we do not have x. Okay, if it is 3x like this, the 3 is the coefficient of x. It's a term, but this one is a constant number. That is a normal number. So we are going to refer to terms where we do not have x. So in this case, we do not have x on a. So we are going to have this equal to minus 8a. We move on. Here we've got x, we've got x, we've got x. Here we do not have x on this part. So this is going to be a negative 4c. So we are having negative 8a, negative 4c. And we have the value of a. In this case, we said a is equivalent to 2. So that means I can substitute this value of a in this case, which is 2. So that's negative 2, negative 8 by 2, which is negative 16. And on the other part, it is going to be a positive. If you transpose, that is going to be a positive 16 is equivalent to negative 4c. That's 20 is equivalent to negative 4c. C is equivalent to negative 5 if we divide by negative 4 both sides. So we have the values of a, b, and c, which we are going to substitute back now into our f of x, which we said is a over x minus 4. So that means in this case, we can conclude that, all right, so let's just have it as a conclusion here. So therefore, our normal expression as it was, that was 3x plus 4, everything over x minus 4. So this is what, this was x minus 4 into x squared minus 8 is equal to, the first part is a over this one, that is a over x minus 4. So we have the a. So that's a over x minus 4. So that is our a in this case, which is 2. So this is going to give us 2 over x minus 4. We move on to the plus, the other part, that is a plus. We've got plus bx plus c. Bx plus c over x squared minus 8. So we need bx plus c. So our b in this case is negative 2. So this is going to be negative 2x plus c. Our c in this case is a negative 5. So everything is going to be over x squared minus 8. So this was over x squared minus 8. All right, which can be simplified further. So I just want us to take a consideration in this case, whereby we can actually factor out a negative, because a negative is common, so you can factor out this negative. So this is going to be equivalent to 2 over x minus 4 minus, the moment you factor out a negative on this term, which is we've got negative 2x in this case. So the moment we factor out a negative, it is going to be a positive 2x. So here, this one is going to be positive 2x. If we factor out a negative, we are going to remain with a positive. So it is going to be positive 5 over x squared minus 8. So this is what we are going to have at the end. So we've got 2x plus 5 over x squared minus 4. This is 2 over x minus 4. So this is what you're going to have as your f of x, or this part of 3x, whatever that you have, or you can write it even as f of x is equal to. So that is a revision, guys, on the simplification or expressing a normal fraction into partial fractions. So that was our question in this case. So let's check the other part of the question from this part that we now have. We are now given on the B part that from the f of x that we are given in this case, hence or otherwise find the series expansion. Take note of the question. We need the series expansion in this case, the issue of series where you expand a certain bracket. But we are given this expansion of f of x when x is small such that terms in x to the exponent of 4 and the higher are neglected, meaning to say any term that is going to contain x to the exponent of 4, like we've got 2x to the exponent of 4 or whatever that we have, 3x to the exponent of 5. These terms, they are going to be neglected, which means we are going to ignore these terms. They are not going to be part of our expression or part of our expansion, which means in your expansion, you are going to have the least the highest exponent as x to the exponent of 3, since we do not want anything that is equivalent or greater than a 4. So which means the highest exponent that you're supposed to have is a 3. Okay, so this is what they're trying to say. But there are two ways. There is hence or otherwise. So in this case, I'm going to focus with the hence. Hence meaning to say continue from the last part. Hence is from this part, from. That is what we are simply referring to as hence. So meaning to say from this part that we calculated in A, where we expressed into partial fractions, we are going to refer from there. How are we going to have a series which does not contain terms of x to the exponent of 4 or higher terms or higher exponents? All right, so that's 7 marks for that. Okay, so I want you to see how to attempt such typical questions if you are given any question of this nature. Okay, you were given f of x previously, and you expressed that f of x here in partial fractions. So if you are to express this in terms of brackets, remember it's possible to convert a fraction 1 over x into x to the exponent of -1. Which means even an expression, it's possible 1 over x plus 4 can be written as x plus 4 everything to the exponent of -1. Whether it's a linear expression or it's a quadratic expression, we can change this into a bracket of a certain exponent. So that is the idea that we are going to have from the partial fractions that you're given. So in this case, you are going to express your f of x. So that is the B part in this case. So we're going to refer our f of x in terms of brackets, because this is 2 over this expression. So it is going to be equal to 2 into x minus 4 to the exponent of -1. We have expressed this in terms of a bracket, which can be expanded. The same way we are going to refer it to this part. Already it's in the numerator, so it is not going to affect us. So it's 2x plus 5 as it is. But this part in the denominator is the one that we are going to write it as x squared minus 8 to the exponent of -1, so that we are having, so that we can expand the brackets. From which concept? That is, now we are referring to our binomial expansion, which states that if we can be given any bracket, let me refer to our binomial expansion, which says that if we can refer, so on your binomial expansion, we've got 2 ways before I express this. It depends with which part are you affecting in terms of the exponents. If you are affecting the exponents of x, it's best for you to write it as a plus x to the exponent of n. What am I trying to say? You are increasing the exponent, the values of x in this case, from x to the exponent of 0, x to the exponent of 1, x to the exponent of 2, x to the and so on, if you write your x on the last part. if you write your x on the first part like this, what are we increasing in this case? We are increasing this a. So it is going to be a to the exponent of 0, a to the exponent of 1, a to the exponent of 2, a to the exponent of 3. So what are you willing to expand is going to be referred from the what? From the question that you are given. In the question, we are given that we are supposed to affect x in this case. So this is the one that is going to give us a reference to say, how are we going to expand our simplification in this case? All right, let me try to refer back to my question. Where is that part here? All right, it's hiding here. This is the question. The question is asking us in this case, sorry for this part, is asking us that hence or otherwise from the series that we are given, find x when is small such that terms in x to the exponent of 4 and higher are neglected, which means x is the one that is being affected in this term. All right, so this is what you're going to have. So since we are affecting terms in x, we are going to focus on x. This is what we have. So which means our expansion is going to be in this format, so that x is going to be affected in its increase, 0, 1, 2, 3, and so on. All right, so now we know which part or the bracket that we're going to use between these two, because it's not like a direct that we're going to use a plus. It depends with the question. All right, so this is going to give us from your binomial expansion, that's a to the exponent of n plus n into a to the exponent of n minus 1 x. So this will be x. Now it was to the exponent of 0. Now it's x plus n by n minus 1. So this is n by n minus 1, a to the exponent of n minus 2, x to the exponent of 2 over 2 factorial. So this was 1 factorial, but 1 factorial does not affect. Okay, so this is 2 factorial plus, so we are going to expand. Remember, we said the highest exponent must be at 3. So let's just expand up to 3. So this is going to be n into n minus 1, n minus 2, a to the exponent of n minus 3, x to the exponent of 3 over 3 factorial. So in this case, for the A level, this topic of the binomial expansion, we never referred to it, but you can even check on other videos on how actually we refer to this, like on introduction, so that it can help you in understanding this part. All right, so we are having a formula which allows us to expand x in terms of a certain exponent, a plus x. So that means in this case, we are going to take the first part here, the x minus 4. This is our first expansion. Okay, so we are going to take this first part, but how are we going to expand it now? It's x minus 4. It's not in form of a constant plus x. So we are going to rewrite. All right, so this is x minus 4 to the exponent of minus 1. Forget about, don't consider the two. Just leave it like that. We shall talk about this later on. So we want to expand this bracket, but in this format. So it's either we are going to change this into a negative, this part into, like to start with this part with as a negative 4. Like you're going to write it as negative 4 plus x like this to the exponent of negative 1. So that this is referring to your a and this is your x. So we can even write it in this way. All right, so if we are to write it in this way, or someone can factor out this depending, some they expand a 1 plus x to the exponent of n because they have this in the formula sheet, so they can take advantage of that. It's your expansion. Whatever way that is suitable with you, you can use that. So if I can have this as my a and this as my x, that means I can simply substitute into the formula because I'm given the formula of the binomial that is a to the exponent of n, which is our a, that is negative 4. So this is going to give us negative 4 to the exponent of n, which is the first exponent, that is negative 1. Plus, if you have to say this n, it's like the derivative part, the derivative. Remember the concept of derivative, you drop the exponent, you subtract 1. So that is the case that you are dealing with in this case. To say we are going to drop this exponent, which is negative 1. Then we subtract negative 1 on the exponent. So it's negative 4 to the exponent of -1, which is -2, just like derivatives. But what you're going to do for x, it was x to the exponent of 0 here. Now it's x to the exponent, which is this one, over 1 factorial. So the 1 factorial does not affect. You can even leave it like that. We move on to the other term. Now we continue from that previous term that we had, which is -1. So it is going to be -1 times, we do the derivative concept, which is the derivative. We drop the exponent, which is -2. We subtract a 1 on this exponent. So it's -4 to the exponent of -3. -2 minus 1, that's a -3. Then on x, we are increasing the numbers. It was 0, 1, this was 1, so it's going to be 2. So that's x to the exponent of 2. In this case, everything over 2 factorial. The exponent of x affects your factorial. 2 factorial. Plus, we move on to this next term, starting with these two terms that we already have, -1, -2. So this is going to be -1 times -2. We perform the derivative concept. We drop the exponent, we subtract 1. So this is going to be -3 minus 4 to the exponent of, if we subtract 1, this is going to be to the exponent of -4. For x, it's increasing its powers. So this is x to the exponent of 2. We increase by 1. So that's to the exponent of 3. Everything over 3 factorial, and so on, and so on, and so on, and so on. So this is how you can expand. So many formats that we have. We are not limited. So if we are dealing with marking guides where we are limited to say, this is what we have. A marking guide is supposed to have different ways, options of answering a certain question, of which they consider this is your calculation actually in the right way. So that is what is important when answering these typical questions. Okay, so this is where we are, guys. We can simplify further. This is now you and your calculator. On this part, it's you guys and your calculator. Okay, the other thing that I wanted you to check, like I said, you consider other topics, other videos that I did before, so that you can actually understand. If you check here, there is something that is happening on each part. This is like we have got x to the exponent also, like I said. If you add -1 plus 0, you get -1, which is this exponent. This is -2, this is 1. If you add -2 plus 1, you obtain -1. This is -3, this is 2. -3 plus 2, you obtain -1. -4 plus 3, you obtain -1. So you must obtain the exponent that you're given, the power that you're given. If not, then it means whatever that you're doing there is wrong. Redo your question while there is time. Okay, so that is the idea in this case. Okay, so in this case, like I was saying, it's now between you and your calculator, guys. So we can simplify further from our expansion here, -4 to the exponent of -1. This is going to give us -1 over 4. So that's -1 over 4. If we simplify this whole part, we are going to obtain -1 over 16x. All right. So you simplify this part, because x is not affected. So you just simplify this part as it is on your calculator. All right. So that is how you simplify. So this is going to give us -1 over 64. So that's -1 over 64 x to the exponent of 2. We simplify again that part. This is going to give us -1 over 256 x to the exponent of 3. So you have expanded, or you have expressed this in terms of what? In terms of powers, but noting that we are limited to say exponents or powers of x to the exponent of 4 and higher, they are neglected. So meaning to say, we are not involving these exponents or these powers that you are given. All right, so that was the first expansion from the given part that we are having this bracket. So we move on to the other part. What we need is to expand these brackets that are being raised to a certain power. So we have expanded the first bracket, x minus 4. We shall talk about this later on. Let's move on to this one of x squared minus 8 to the exponent of 1. So I'm just going to expand this separately. So this is your calculation 1. We move on to the calculation 2 of the bracket. So we have the bracket of x squared minus 8 to the exponent of -1. Like I said, depending with the expansion that you're given. In this case, we need exponent of 8 increasing, exponent of x increasing. So we're going to rewrite starting with -8 followed by x squared. So this is the same as -8 plus x squared to the exponent of -1. This is what we simply have in this case. So already the first term of x is actually to the exponent of 2. So which means when we are simplifying, take note already that we are having the highest exponent, which is to the exponent of 2 there. Okay, so we are going to expand. Remember, we say this can be given as the first term to the exponent of n here. That's a to the exponent of n, of which our a in this case is 8. So let me just write as a and x so that you understand. So this is your a, this is your x. So that means a to the exponent of n, which is our exponent, -8 to the exponent of -1. Plus, remember I said you apply the derivative concept. You drop the exponent, that's a -1. We subtract a -1 on the exponent, so that's -8 to the exponent of -2. -1 minus 1, that's -2 to the power of -2. At that moment, x is now appearing, but it's appearing as x to the power of 2. So this is x to the power of 2. Take note. So everything that we have to the power of 1, because that is where that is what you're supposed to have. Take note here, guys. We are having x being raised to the power of 1 on this part from that x that we are having. So in this case, it's given as x squared, but being raised to the power of 1 as per our notation. So that is what you're going to have, and everything over 1 factorial. So this is going to be over 1 factorial, and so forth, and so forth, and so forth. So like I said, 1 factorial does not affect. If we are to consider this next, I want you to see something. If we are to consider this next term, it was going to be -1. We drop the x, we now apply the derivative concept. We drop the exponent, -2, -8. We subtract 1, which is going to be -3. Now this x squared, which is representing our x, it is going to be raised to the exponent of 2 over 2 factorial. But I want you to see something. This whole part is not going to be part of our question. Why? X to the exponent of 2 to the exponent of 2, when raised to the exponent of 2, it is going to give you x to the exponent of 4, which is higher or equal to x to the exponent. It's not needed. From x to the exponent of 4 or higher, we do not need these higher exponents. So that means if our x is small, x to the exponent of 4 is not involved. So this part is going to be out of our expansion. So we just need these two terms. All right. So that means this whole part of x squared minus 8 to the exponent of -1 is going to give us, we simplify, negative 8 to the exponent of -1, which is -1 over 8. You simplify this just like the previous part, you are going to obtain -1 over 64, -1 over 64 x squared from this part here. So that is what you're going to obtain in this case, of which you can just leave it like that. So you have the expansion of x squared minus 8 to the exponent of -1, which is this part, and so on and so on and so on. We can't have the next term because once raised to the power of 2, it is going to give us a 4. So that's why we are ending at this term. All right, so now we have got the expansion of x squared minus 1 minus 8 to the exponent of -1, and also the expansion that we did previously here of x minus 4. So let me write here x minus 4 to the exponent of -1. We now have this expansion. So let's refer back to that normal, to that previous expression that we were given before. We were given this expansion here. This is our f of x. So I'm going to rewrite this so that we can understand now how are we going to have our final answer now. Before, we were given that this f of x that we are referring to, it is given as 2 into x minus 4 to the exponent of -1. That was negative 2x plus 5 into x squared minus 8 to the exponent. This is what we are given from those partial fractions, the next step. Now we have expressed this part here in expanded form up to the exponent of 3 in terms of x, which is this one that we got here. So we are just going to substitute now because we have this expansion that we got on this part. So you're going to substitute everything as it is. Everything as it is. All right, so let's substitute this part of x squared minus 1. So this is going to give us f of x, which is equivalent to 2 times, remember, we got -1 over 4, -1 over 16x, -1 over 64, x squared, -1 over 256 x to the exponent of 3, and so on and so on and so on. So this is what we're given. Minus, we move on to this part. So I want you to be very, very careful in your simplification whenever you are simplifying your questions. Okay. You can multiply this part by a negative. The moment you multiply this bracket by a negative, this is going to be a positive. So that means we are going to add everything, or you can just leave it like that. Okay, so that I do not confuse you. So let me just leave it like that, since we are going anyway, we are going to expand this bracket. Okay, so this is going to be minus into 2x plus 5 in this case into the bracket of x squared minus 8 to the exponent of -1, which is this one that we got here. And in this case, we got -1 over 8. So this is -1 over 8, -1 over 64 x squared. So that's -1 over 64 x squared plus, and so on and so on and so on. All right. So now you can expand your f of x. That's a series in terms of powers. So you can expand this expansion. By expanding this, you are having your f of x in simplified form or in simplified manner. That's how you simplify these typical questions. Okay, so let's expand f of x. 2 by -1 over 4. This is going to give us -1 over 2. 2 by -1 over 16. That's -1 over 8. So we're going to have -1 over 8x, -1 over 32. -1 over 32x squared, -1 over 128. So this is going to be 128x to the exponent of 3 plus. And so we know that there will be so on and so on and so on. So that one is not a matter of fact. So now let's get back to that concept that I was referring before. We are going to add, but how are we going to add? Instead of expanding, then we multiply by negative. We are going to multiply by this negative. Negative times 2. This is going to give us -2x. Negative times 5. This is going to give us -5 like this. The moment you use this negative in your expansion, it's no longer valid. You have used it, you have applied it in the first bracket. So this is going to remain as a plus as it is. So now we are going to multiply -2x by -8. So this is going to give us a positive 1 over 4x. All right. We move on. -2x by -1 over 64 x to the exponent of 2. This is going to give us positive 1 over 32 x to the exponent of 3. This is x and x squared. So it's going to give us x to the exponent of 3. We move on. -5 by -8. This is going, -1 over 8 is going to be positive 5 over 8. -5 and negative, this is going to give us a positive 5 over 64 x to the exponent of 2 plus, and so on and so on. So you can get rid of the negative by expanding the first bracket. It's fine like that. It's fine like that. You can get rid of that negative. So how now are we going to simplify? It's a matter of terms which are common, which are like terms in this case. So you're going to refer to your like terms. So that means constants. We have got -1/2. We have got 5/8 in this case. So if we combine, we are going to combine these terms now together. That is the like terms that we are referring to. So that means our f of x is going to be equal to -1/2 plus 5/8 is going to give us that's 1/8. We move on to x terms with x. So that's -1/8, okay, plus 1/4. That's what we only have in this case. -1/8x plus 1/4, which is going to give us 1/8. So just cross-check also with your calculator. So that's 1/8x. We move on to the x to the exponent of 2. In this case, we've got -1/32. Also, we've got a plus 5/64 in this case. So if we add this, this is going to give us 3/64 x to the exponent of 2. We move on to the exponent in this case of 3, that is -1/28 and 1/32 x to the x. This part can be combined together. So this is going to give us +3/128. So that's +3/128 x to the exponent of 3 plus and so on and so on. All right. So if we check on your final answer, you are only having the terms or the value, the part that is got x, the powers that are there are of 3 and lesser. 3 and less. Any part that has got x to the exponent of 4 or x to the power of 4 and so on is not involved in this expansion. So this is what the question is referring to. Can you write it in terms of a series that is sum of terms? That's a series. You are adding terms together. But on the terms that you're adding together, the highest power is supposed to be of 3. That is going to be small. All right, so that was our part of the question in this case. So guys, you have to revise more questions from your partial fractions. They can have they can give us questions like this where you need to apply now your partial fractions into detail. It's not about expressing a certain term into partial fractions only. It can be also the application of your binomial expansion. Sometimes it can be an application of integration from our partial fractions where you are integrating certain partial fractions. I think I talked about that typical question. So if not, guys, make sure that you watch other videos that we did on integration, on partial fractions so that you can understand more. From Meson African motifs, till we meet again.